All right, let's go ahead and get started. Okay. So maybe I should start in reverse order. So we'll go with Alex Morgan. Okay. Okay. Let's see. I need to share my screen here. So I do not see any retention area graded. So you asked about your contours as well. We can take a look at the dropping contours, and when I go through other folks' retention area, please watch. Then you will know how to get started on the retention grading. So I'm trying to get a sense of where your original contour is. It does seem your building is really close to your drop-off and your parking lot. And it's likely your parking lot has more parking spaces than necessary. It's probably a little too late to modify your parking lot design. But I think at least what we can do is to move your building back so that you have a visible plaza space. So we move our building somewhere here. I'm trying to map out your original contours. Your 50 feet offset, it's not exactly right yet. But I'm trying to get a sense of, okay, so this is the original contour. That is the next one. So I'm still missing on this side. Once we move our building, I would actually, let me try something here. You could also make it shorter. But that also means that your ridge line is changing direction, which is okay. Okay. So when you drop your contour in your parking lot, things only change. Then the contours only change on the part that is below the curve. Okay, so these are where the contours will be dropped. Well, I need to move it because you need to go midway. Better just delete it and start over there. So those contours, make sure they're in the middle, okay? By offsetting, if originally you had a 2%, you offset it by 25 feet. Okay, so that is this portion. Need to keep going actually. And that one. And then there is well, once you get up to the curb, then you don't need it. So this actually stops at the curb. You might have another one here, depending on how much area, well, how far the curb, the most distant point of the curb is. If it's over 25 foot, you will have another one on this side. Okay, now you need to kind of connect them. I'm going to show just to, go back to the pink line. The ones that are out of the parking lot, they stay, right? So you need to connect over here, right? Because the dropped contours are under the curb. So the top of the curb will be at the same elevation here. I have no idea because the contours are not numbered, so I'm not sure what they are. Gonna try to figure it out. So this is 10. Nope, that's 5. This is 5. Let's get 4 here. And then this is 4. And that's 4. 5 there. I need to move it to the pink line there. So going back to the pink line. So this one, you would go along the curb, okay? And you have a little bit of 5 over here as well. So I'm trying to figure out how this curb kind of intersect with your with your offset line. Best advice is actually you need to go back to your contours and make it precise, right? We have to know how exactly these contours intersect with your curb so that we know in which direction it goes kind of around along the curb and then reconnect. For instance, if this line actually, lands in or intersect with part of this screen, then you wouldn't have, you would have a little bit of 5 across here. So it really depends on the actual measurement of where the contours land. So in this case, if it doesn't intercept at all with the screen, then you come back and then go like this, right? But then there's a little bit portion here, we need to figure out where it goes. Let me try to remove the ridge line so that I can see a little bit better here. So we know this portion needs to stay. It's like, yeah. So if there's a curb continuing over here, you actually have a little bit portion along this curb, and then you go along the curb again and can connect back to the 5. So these 5 and 4, I would say, is the most difficult. So in terms of 4, you would go again to connecting back to the 4 of the original, and then this would be your 4. Okay, this 4 would need to connect wherever 4 is over here. I haven't checked these numbers yet. I'm a little concerned that you might, let's see, if you have 6, you have 7, and then you have 8 and 9. So you're only at 9 over here. And remember, this is 13. So I'd say you probably want to change the numbers systematically. Okay, we'll take a look. So if I am at 9 here, 10 is around here. Well, at this point, you should start transitioning. So even if we go pretty steep, I would say 2 more contours here. So you have 13, you have 12, 11. So basically, you just need to move the contour number down by 1. Okay, so those are how to modify your dropping of the contours. It's a little hard for me to move all of them. Okay, let me try. Just do this. It's too big. Well, I'm not gonna do the all of them just because this is not a really friendly tool here. Okay. Okay, we did it anyway. Okay. So these are the contours that you need to modify. For these ones, they're relatively straightforward. You need to follow the same logic. The contours on the parking lot needs to be on the higher side of the contours on the original vegetated area out of the parking lot. So first, you do need to go back to your contours. I would say if no significant efforts, kind of level of efforts change in the next few weeks, you probably should consider the late drop deadline. Okay. I know that's discouraging, but we don't want it to be too late to give out that notice. Okay. So I'm gonna move forward. Next one is Graham. Is Graham here? Okay. So I see a couple of retention areas here. So you have LP, you have HP, but you do not have let me try to rotate it. So I'm seeing some major issues with the contours. We're at 11 here. We're at about 13 over here. So you can see, the area between your 1113 and your 1111 is also too flat, right? And then the contours are not all parallel to each other. On this side of the ridge, the parking lot contours a little confused about why these contours are, going this way or turning just a little bit. If this is your ridge line, your your contours should look like this. Okay, and this seems to be before the dropping. Yeah, that seems to be before the dropping. And your contours should look like something like this so that you create a swale. Okay, so this is, if these are your original contour, it would look something like this to form the swale. And I'm trying to, yeah, that looks reasonable. And this would be your swale. And that one goes through your turnaround area, which, at this point, I wouldn't modify anymore unless you're willing to, shorten this whole driving aisle and push all the parking lot toward that direction. Otherwise, you will have to run your water through your drop-off area. So I'm gonna quickly talk about, well, so I deleted one of the contour. Well, maybe I'll just put it back here. So I can see that the dropping of the contour did not come through yet. On this side, it worked, right? Some of the contours still not parallel to the other contours, or they're not exactly halfway. But something, something worked on this driving aisle, but not on this parking lot. Okay. So the brown only stays in the brown contour only stays on the vegetated area. All the parking lot contours needs to be offset by 25. Okay, so that looks like it should be here. Let me modify it. Yeah. So this was the original one. And then you'll just keep offsetting 25. Well, if you use the pink, you offset by 50, right? So this will be your new 11. If no, suppose 11 is still here, but 11 shouldn't be here because you have 13 over here. All right. So you do need to modify the contours first. Let's zoom in to this area and see the retention area here. Okay, I'm gonna just make a guess what this contour number is, or make up one. Okay, so if you have 9 here, is that a 9? Yeah, that's a 9 contour. Looks like you have a 9 contour here. What you need to do is you first need to decide where your curb cut is, right? If your curb cut is somewhere here, you need to calculate the curb cut elevation based on the difference, based on the distance from this curb cut to your 9 contour. For instance, if I'm to estimate it, I would say this is 1108.6 or 7. Oh no, maybe 7. Okay. If that's the curb cut, I'm not sure why you have 1098 though. If it's 110, yeah, it is 1108.7. Your if there's no RDI here, you would basically use your curb cut as the highest water level, right? So your water depth is to be kept under 1 foot, meaning that your LP needs to be 1107.70, okay? And in that case, you would have a contour here that is 1108, right? Because the surrounding elevation is 89 and your LP is 1107.7. So you would have a contour that is 1108. And we need to look at, by the way, the contours are connected back, in a different, in a wrong direction. Your 9 is this one. Okay. Always remember the ones that are on the parking lot or driving aisle, that portion of the contour is on the higher side of the contours that are on vegetated area, because here the TB will be the same as the other contour. Okay, so let's see. If this is a 9 contour, you have 08 contours, then your 8 contour is over here, which means my high point will be between the two 1108 contour. Okay, so your 08 is here, and the HP equals to 08.5 would be between the two 08 contour. So that is the basic of designing a offline retention system along the outside sort of edge of the parking lot. You don't need an RDI, you do not need DI, but you do need a CC, two HPs, two LPs, and a contour number. I would say this is the same idea. Okay, this one is the same idea. You did two of them, and then there is another one on this side. I wouldn't put a retention area here because water is not draining that way. Okay, water is not draining that way to the edge of the plaza. This is draining this way. Okay, so your retention needs to be basically, well, not that. Actually, your retention needs to be in this shape because you're sheet flowing basically from the back plaza to a retention area. Okay. Okay. Anything else you want me to go through? All right. This is also, I want to give up that warning. This is also a case where you need to increase your effort or you need to consider the late drop deadline. Next, we have Nicholas. You here? Okay. All right. I am seeing a few missing contour lines in this green area here. Okay, it does seem like this is halfway, about halfway. So we're missing a closed contour in this area. Let's zoom in to the corner. So the corner, you have a situation where you definitely need a DI or an RDI, okay? Because this is a dead corner. If there's no DI or RDI, water will not be able to keep flowing downstream. So you need an overflow mechanism there. So I would say you do need to add more contour labels here because, for instance, when I'm zooming in to check the retention, I need to know what contour number this is, right? So at this scale, I have to be able to, let's see. This is good. You're labeling outside of the parking lot, but make sure you label them inside the parking lot as well. And this is the 08 contour. Okay. BC estimate seems to be good because you are at 7.13. And then your LP is less than 1 foot below the DI, so that's great. And because of that, you have an 07 contour, and then you have HP between two 07s. The place you put the 07 is not correct. Now you can see that the 07 of the retention is actually conflicting with what you had. Does that make sense? Your 07 was there. What does this mean? This means you need to push your original 07. Does that make sense? And keep pushing your 06 like this. Does that make sense?
You said push the original 07 past the high.
Yes.
Okay.
You cannot have two contours conflicting with each other, right? And then your OHP should be in between them, right? Between the 07. The point of the HP is to create that berm, right? Create the berm so that the water doesn't flow over to the other side. So these two HPs needs to be between your 07 contour here and your new moved contour. Okay, so that's that. Otherwise, I think it's pretty good. Don't forget, for these CC, you also need to be at top of the curve, right? You need all of them. Yes. Okay, so that is good. Let's take a look at this one. So this one is you know, you chose different location for your retention, so that's really good because then you can have you know, get feedback on different types. So this is along the swale. I just want to remind you that you do later on, you do need curb cuts over here, right? And curb cuts over there. Does that make sense? Or no curb cut. Yeah, okay. No curb cut over here, but you have to have a curb cut over here. Otherwise, water won't be able to flow into the retention, right? You don't need to open this up, but no, this portion, the everything below that point will flow to your curb cut over here. So that's covered. But you definitely need to open this up. All right. Okay. So we'll keep going, zooming into that area. Again, you do need to try to estimate the 06.91 well, we'll take a look. I'm suspecting that you missed a contour here. So if that's the swell line, and trying to see, you would have one more contour here, right? If you drop below 7 here, you have another contour, you know, that is a closed contour. Does that make sense?
Yes.
Yes. So based on that, you have an estimation of the DI equals to 6.91. That's good. Then and 6.5, that works. You have a 7 contour, and yeah, this totally work. Because this is the end, I would say you can lower your LP a little bit more, like 1 foot below your DI, because you need more area or more volume here. Does that make sense? So make it deeper because this is the end of the pipe, not the pipe, end of the chain. All of the water that wasn't absorbed or intercepted by other retentions will be flowing down here. Okay. I noticed you have a curb cut over here. That's not necessary. Reason being, we are on the plaza now. Okay, the plaza does not have a curb. Okay, plaza does not have a curb. The curb are only for the driving aisles and the parking lots. Okay. So 2 good examples already. Let's see. Did you do a third one in here?
Yes.
Okay, let's see. So this is another one where you have a swale going through. Let's see. I'm trying to figure out if that's about where it comes in. You have quite a bit of water draining to sort of the plaza will drain into the drop-off area. If possible, you could, no, I would say in an ideal world, you could have a trench drain kind of at the edge of the plaza, something like this. Because then all these water from the plaza area will be able to be collected through this trench drain along the edge, because that's clean water, right? That's clean water, and we would want that water to be treated. You can pipe it down. Let's see, where would you have, well, you have a lot of green area here. Is that right? You have a lot of green area. Yeah, I think it will be good if you could drop that water down to this area. You know, you can use this to treat all the relatively clean water out of the plaza. Now we can be even a little bit more aggressive and say all kind of along this plaza, everything is collected by the trench drain here, and then it's dumped down here. So that way you separate the relatively clean water from the plaza. Otherwise, it's just gonna drain to your drop off. Does that make sense? and then it's mixed together. It also increases the volume that's collected, it increases pressure down here. So that's one suggestion. Not necessarily have to make them, but I should mention it at least, right?
I do have a question about the trench drain.
Yeah,
Even though it's going through kind of that center swale line, will it all drain to the left? Is that what you're saying?
yes. And so that means you need to find where is the lowest point. I would say either these, like on top of the plaza, these two seems to be at the relatively kind of the same elevation. So you would calculate this one and two at the end and make here. So if I'm doing cross section, you would want the drain to drain this way, right? And then wow, all the way, honestly, all the way down could be a little too like this. The bottom would look like that. And then here you maintain like half a foot deep. So you would calculate basically a 2% slope from along this edge. Okay, along this edge, using the top, like the edge of plaza. And here down at the bottom would be bottom of trench drain equals to that edge minus 0.5. Okay, and then measure the length of the trench drain and all the way down using a 2% slope here. Okay. 2% slope down. And then you get the bottom of the trench drain equals to the other bottom of the trench drain minus that elevation drop. So it could end up pretty deep, meaning that if we were to do the design of that, it will have rocks, to prevent erosion. And that is sort of your, the bottom of the trench drain out of this point would be where the highest water level would be. Does that make sense?
Where the trench drain would exit out?
Yes. Yeah, so the BTD equals BTD2 is sort of the entrance of the water, right? And if we were to design an RDI here, it will be equal to BTD2 minus 0.5. Does that make sense? Mm-hmm. Yeah, and then you just use that relationship, but you could kind of imagine that's a pretty deep. You sort of have to cut quite a bit to form that hole. Yeah. Yeah, okay, good. All right, so that's a little bit of extra, but then we can return to the central green that you just designed. Okay. Curb cuts over here. We don't have curb cut elevation yet. We do need that. We do need this and the TC here. I still need to figure out what the elevation here is. So this is 7, I believe. Yeah, that's 7. Nope. This is 7, that's 8. 8 and 7 here. Okay, this is 7. Is that correct? Yeah, this is 7. This is 7, and then I would say your CC or TC would be, 6.45, something like that. Oh, sorry, my bad. 7.4. And then your RDI equals to 7.2. That's okay. Well, you can push it a little bit down to 6.9, and then your LP equals to 6.5. That's okay. And you have a 7 contour. Make sure that you add the contour number here. Okay, that's 1107 again. And then your HP. So that's good. Let me see if we're missing a contour here. I think we're probably missing another contour. If we have 7 over here. No. Yeah, that's about where. And you're actually going halfway down, right? So actually, we're missing a 7 contour on in the green area in the middle. Does that make sense? Yeah. So I would get rid of this portion. So you have these two, but you actually need to do this. Does that make sense?
Yes.
Yeah. And then you likely have a little bit of, I think you might have a little bit of 6 down there too. Double check. And yeah, that's probably like this. That's a 6. So in order to accommodate your retention area in the middle, what you can change is you can change, you cannot change those because those are determined by the contour and the kind of the curb. It's remain half a foot. So these two connection points wouldn't change, but you could change the 1107 in the middle because this is vegetated. Okay. And then you have a 007 contour, so your HP will be between these two. Does that make sense? Yeah. So overall, good work on these 3 retention areas. Anything else you want to go through?
No, I don't think so.
Okay, great. All right. I'll move forward. Next, I think it's Pega, right? Yeah, cool. Okay, check the contours on ramp and give me some suggestion how to solve the contours across the road. Do I need retaining walls? If yes, where can I add it? Driveway, check the retention. Okay, is the way that I diverge the swell, well, it could still be improved a little bit, but overall, the concept, you kind of get the idea. Yeah, you need to diverge a little more. Okay. So let's see. Okay, where do I start? Well, let's start with the retention. Okay. You want me to check the retention at entry of the plaza. Is it here? That one? The middle of the parking lot? Somewhere here or somewhere here? Okay, cool. All right. We'll start with this one. I can immediately see there's something that could be improved. This is the different type. Okay, this is the first time we're going through in this review session, the plaza one, but no, let's start with constructing a cross section. On the plaza, there's no curb if you don't create one, right? So it's basically just going down like this. So you can kind of see the problem that, we're cutting from this point on, starting from here, right? We're cutting it down. So there's a few different scenarios. You could say, okay, I don't want it to overflow from here. So my water is just going to be this low. And that is going to be defined by how high this is, basically how high that is. Does that make sense? But if I'm saying, okay, I do not want it to just, dig a deep hole. No, from this side, it will look pretty deep, right? So I want to raise this on the other side so that I can at least have this much water. Does that make sense? Yeah. And on a plaza, because, space still relatively limited and you are on a plaza, so very likely you are actually, if this is the second scenario is what you need, you likely are going to create a little bit of wall here along the other side, right? So the wall will be around the lower side. Does that make sense? Yeah, so the way to demonstrate that is using the B wall and the T wall. B1 T wall, depending on how high you want this to be. Okay, so your RDI is quite low. You're at 1107 here, and your RDI is 1105.5. That may be because you are trying to use this as the lowest point. That could be the case. Oh, either way, honestly, either way, it's a little too low. Reason being your 1106 is here, which is a little, oh, yeah, that makes sense. So basically, if water starts from here, your elevation at here would be 1106, probably 06.8 here, right? 1106.8. And then here, you're at about 1106.4. So here is 1106.4 here. If you say, okay, I do not want my wall here, I just want to use the lower point, then I'm just now gonna use 1105.9 as my water level. That's my RDI, right? Okay. And then you would have a 11, well, I would say 1104.9 would be your low point because you don't want to exceed 1 foot deep, right? So you would have an 05 contour, the correct. You would have an 06 contour, that's correct. And honestly, you do not need you do not need any HP if we're just using the 1104 here. Does that make sense? Oh, sorry. Yeah, so this is a little different from when we are in the parking lot or no, at the end of this the swale here. You do not, if you are using this, unless we're creating a berm, you do not need an HP. Okay, yeah. All right, so that's that. Let's take a look at what's happening in the middle. We'll do this one, okay? You have an RDI here. If you have an RDI, you do not need a DI, all right? So 07.64 for curb cut is 87. That's 7.4, all reasonable. And if you have a DI, you do not need this RDI, okay? We'll just use the DI here, 0.74. I would raise the LP a little bit because you're exceeding 1 foot there. And then you have an 06 contour here. That's the 07 contour. In this case, oh yeah, sorry, you have a 5.74. So you have 2 contours here. Yes, you have a 6 contour and then you have a 7 contour. So we're missing a contour here. And your HP will be between the 2, 7. So that's correct. Okay. All right. So remove the 8 RDI, add another contour, then you're good. Same thing, you do not need an RDI here. You can have one, but it's more money, right? If this fills up, it can just keep flowing down. Yes. Okay. So you asked some help on the ramp. Okay, I think you got the idea. Only, well, the thing that I would change is I would add some side slope. Okay, because you do not want your water to drain longitudinally along your, no, exactly along your ramp. No, because it will cause accumulation of ice during the winter. So you would want it to, no, more fastly drain to the side. So in this case, you would turn these contours so it has at least a 2% side slope. Okay. Yeah, that's the, well, and then from, this is more or less 5%, basically 20 foot apart. That's good. Well, the more complicated thing is when it gets down to here. We'll need to see if it connects well, right? So we have a 7 here. I'm a little concerned about where your 6 contour is. Just double check once you offset this 07 by 50 where that 6 is originally, okay? I'm not sure if this is too flat. We just need to double check. I'm not saying I'm confident that it's not, but it could be, it could be close to be kind of flatter than 2%, right? So, that looks good. This looks less than 5, like 5%. Reason being, if this is 20 foot, you are already at 6.55 here. So this distance should be half of it. Does that make sense? From here to here would be actually half of 20 foot. Because you're calculating based on these elevations. All right. So you have a little bit more room, which is, the first portion of the ramp being flatter. That's a good thing. Yeah, because it gives people like, they prepare to enter the ramp. They would expect this not to be as steep as, the regular part. Okay. When we go down, we need to see where your 08 and your 07 is. So I can see a little bit of problem here. You're at 97.26 and 98.31. You are at 1098 here. That doesn't happen. Okay. I am a little confused about the 98. There is something that's not right. This, I think this is 97.31. Because you're at 97 here, right? You're at 98.09 here. So here you wouldn't raise. Now you can see this probably 7.31. This could be a typo here.
I think I used to present from 1098.9 09.
Mm-hmm.
Calculate the distance.
Right. You are higher here, lower there.
Oh,
So I think this is a typo. I think this is 97.31. Okay. And the other thing is if you have a 97.26 here, there is a step here. Does that make sense? Your 998 conflict with your 97.26. So I think there's a way to change it. You could change this. Okay, move the 06 up because you only need 10 feet there, right? Yeah. And
2% is so bad.
oh, it's okay. You don't have to. I'm saying no. It's not a bad design for you to have a flatter area in the front, but now you're lacking space over here, right? So you kind of move these contours up for 10 foot, and then there you go. You might still be short a little bit because you can see your elevation difference here is 0.7, right? 0.7 and you have 0.5 here. So you might need to make your ramp a little bit longer. Yeah, but the idea is right. And I can see actually you wanted to turn the contours, but you turned it in the wrong direction. You actually need to turn it away from the wall, okay? All right, so that is your ramp. Retention wall here.
The upper side of the lower side of the ramp. Then cross the
This portion
No. Here. Down.
down. No. Oh, you mean here?
Yeah.
Well, you are still, let's see. Yeah. Yeah, it does feel like you're, having difficulty connecting to the original contour in this space. I would say yes. Retaining wall will help you
Which side of the ramp?
on this side. Yeah, on this side. Well, you will probably attach the contours all over here. And Now, once you get to 1097 or 5, you should be able to return to original grade. Well, I would say try moving these contours first up to 25 feet, 25%. So move them as much as you can and see how many contours needs to be attached to the wall. Yeah. Move this area first and then go back to here. Okay. Cool. Good question. I didn't catch it before. All right. You mentioned entry road. Yeah, entry road. Well, your entry road works. You don't need to move it anymore. You could remove some of the curbs here. Yeah, remove some of the curb here because the curb is kind of conflicting with these original contours, right? At this point. So you can start the curb somewhere here, start the curb somewhere here. You do not need curbs over here, and everything else, they work. Okay.
And I should also reverse a little bit more this one something.
Yeah, okay. Your divergence swale. So the idea is that water here cannot drain in there, right? So the point is that this needs to be before that. So you would want to drag it up a little bit more, but overall, it's you get the idea. So this is, I think, not until a week later. Yeah, but you can start making those changes. Yeah, and you just want to make sure that for the same number of for the same contour of the same number, this point of the swale is on the upper side of that. Yeah, then you can see water just drains down here and then keep draining down, right? There's no chance for water to go this way and then get into there. Okay, all right. Good, we're good?
And also, do I need more retention, fire retention?
Let's take a look. Plaza area looks good. You have the roof garden, good, you have that. I would make this bigger. I would make this bigger because this is only a pretty small, you can see the drainage area. If you don't collect water a different way, the drainage area is only this big. So I would make it bigger. Like that. That makes sense? Yeah. And you would also need another one. Yeah, you need another one at the end of this swell. Here. Okay. One thing that I noticed, this is the curb cut here is not at the lowest point. You need to find the lowest point, meaning the point has the longest distance to the upper contour. That's the lowest point. Otherwise, you would have ponding water. Does that make sense? Yeah. Here you didn't write, but here you didn't choose this point. Yeah. Okay. Good. Great. Let's move forward. I think next one is Max. Max here. Okay. So I see you get started on this side. Let's confirm contour number first. So this is the 10 contour. Okay, good. So curb cut 7.5, RDI 9.50, good. 9.0. You have a 1100 contour there. All good for this one. And for that one, this is the 8.69. 508. Yeah, this is all good too. So those are the two. Okay, I'm seeing the third one here. This one, yeah, my suspicion is that your contours are not dropped correctly in this area. So let's correct that. All right. So because you're forming a swell here, this one needs to continue going until it hits the swell line. Okay. And then no, that one would be parallel to, maybe you had the connection point correct. So that should be which number? I'm trying to look for. This would be it's a 6. I think it's a 6. This is a 6 contour. You wouldn't have a 5, but your 6, yes, your 6 goes out like that. That's your 6. That's correct. And you have a parallel, that's right. 6 should go that way. Turn your contours, okay? Turn your contours away from the wall so that it doesn't drain along the wall. Your 6 should be going that way. And all right. So those are the contours, and you have a curb cut. I think your curb cut is calculated a little bit too low, unless I messed up with the contour number, which I don't think. Yeah, I don't think so. So here you are probably at around 5, and you are a little bit too low. If you are at 1104.75, you would have another 5 contour, which it doesn't seem to be the case. Okay, you wouldn't have a 5 contour in the parking lot here. So let me clear and then zoom in. So this will be slightly above 5. Let's pretend it is 1105.1. And then you can raise your RDI here and raise your LP, and you would have actually have a 6 contour. So the contour number is not correct. And your HP should be between the 6 and the other 6. Does that make sense? Yeah. So recalculate the curb cut here based on the revised contour. All right, so that's the third one. So let's see about the other. Yeah, generally the first two are perfect. And the third one, I think, is due to contour error. The curb cut was not calculated correctly, and you need to raise it and then raise the RDI and the LP and change the contour number accordingly. How should I create retention area along this wall? Well, you would have retention right in between these two contours. Okay, so basically like that. I know it's gonna be hard to draw. How wide is this?
I think it should be 5 feet.
Okay, then you could do a double wall system. Basically, that means your cross section looks like you wouldn't have a shallow. You would basically just have something using your curb. It's not a 0.5 foot curb anymore. It will be a retaining wall, and your water level is just like that. So previously we're trying to create something when we have more space, something like this, right? Now we just turn it into double wall system, and both of the curves become the walls, meaning that your contours will just run along the curb. Does that make sense?
Okay, yeah.
Yeah. It's a little skinny, but 5 foot, you can still do something about it. Okay, so that's that. You have a drainage. Yes, that is actually receiving quite a bit of water. So, well, it's the same logic. You would have a DI here, and then the retention will just be in this area. Okay. Yeah, because this is if we're not creating, if we're not creating a retention or in between, then unless, honestly, unless your last curb cut is very close to it, then you only have a small, relatively small kind of drainage area that drains or pond here, then you can have a DI. Does that make sense? Yeah, so I would say, as long as we have to create, cut the curb to treat the water, we'll just put it here. We'll just put it there. And next one is, how would I create a bioretention area in the cutouts on my, okay. In the cutouts of your, well, these locations are good. This is kind of the Pega's, Pega, when I showed her how to create a retention area, again, you would start with drawing a cross section, right? If we're here, we're still treating about this much water, so it's still pretty significant. So I don't see the need for you to say, okay, I need to create another trench drain and collect more water. This is pretty significant already. So I would say no trench drain from other areas, just this brown area that I just delineated would be good. And so you start by calculating the plaza elevation of these two, right? So that's your plaza elevation. And then you decide, okay, what kind of cross section do I want? Do I want this one, no, pretty steep, using that as the reference for my RDI, or do I want a wall here? And then my water can raise up to here. Does that make sense? Yeah. No, given this is pretty small and this is on the plaza, I would advise on the second solution. Okay. I can even do a wall over here. That is not a bad idea. Okay. I can do a wall here, but I don't necessarily have to. I can do one wall at the end here, and then no shallow slope, gentle slope on the entrance side. But then I calculate using the calculation of this elevation to determine, okay, my RDI level, you need an RDI here, right? Because there's no other way for water to drain out once it's full. So you use the RDI equals to 0.5 below here, and then your wall will just be at the same level of this entrance. Does that make sense?
Yeah.
Yeah, but you do need to indicate I have a wall here at the end, at the lower side of the retention. Okay? And then you would use like top of wall and bottom wall elevation to indicate it. So it's a different present representation from all the other areas. Good? Okay, great questions. Same thing here. Okay, same thing here. I think by having a retention in this area, you're also receiving a significant amount of the plaza proportion, like 50% of the plaza, so that works. Okay, good. Zoom out. You have something here. No, you do not need anything here because water is not flowing that direction. Water is flowing this direction, unless you have a trench drain which directs into this. Which in your case, I don't think you need to. Okay. So that is that one. All right. How am I to interact the swale that's going on here? That is for next week. Next week we have a divergence swale lecture. So you don't have to, at this stage, when you submit this exercise, you do not need to work on retention in this area. Okay. Let me make sure. Exercise 4 is for all the retention or for 3? Do you remember? Okay. I want to make sure that I give the right advice. Spots, slope, we find, yeah, a minimum of 3. Okay. So you do not have to worry about this. You can start later on once the divergence swell is in. You might need to move the location of that a little bit, but I don't think, the spots will change, the contours will change, but you don't necessarily have to work in this area just yet. Yeah. Okay. Anything else?
I think that's.
Cool. All right. Is Janice here? I think she's traveling. Okay. Maddie. Okay. All right, let's take a look at the retention here. So, well, curve cut calculation is a bit off because this is very close to 1108. So this is likely 1108.1 or even less than 0.1. Okay. RDI could not be higher than curve cut. So your RDI would be 0.5 below the curve cut. Yeah, well, at this point, you probably do not need an RDI because water will keep flowing down. If you want to have an RDI, it will be below CC, okay? And then LP seems reasonable. Yeah, LP is reasonable. And you have an 08 contour. You do not need an 09 contour. Yeah, you do not need an 09 contour. Because on the lower side it's 8, on the higher side it's 9. So you just need an 8 contour to prevent, well, your landscape here is above 08, so you definitely have an 08 contour. So you only need a berm between the 2 8. Okay, so remove the 09 and your HP would be between the 8 here and the 8 in the retention. Okay, recalculate this, get rid of that or lower it down. LP works, 08 works, no need for 09, and HP equal to 8.5 would be between the 2 8. All right, so that is the this retention. We'll take a look at the other ones. All right, we have something in the middle of the entry plaza. Yours is a little different. Let's see. I'm trying to understand the entry plaza contour design. So there's something about the contours that are not correct. The reason being you cannot have the parking lot contour connect to a plaza contour across the curb, right? So this portion should only be in the parking lot. That is in the parking lot, and that is in the parking lot. So let me try to use a different color for the original ones. Original ones look like this. And then this one, I'm trying to find your ridge line. Something is a little off. This seems to be, yeah, either the ridge line or it feels like the original one should go like this. Is that right? So that's your 10 contour. original one. That's the 10. Yeah, something happened during the dropping of the contour and made your ridge line move to a different location. Okay, 11 goes like this. Now give me a little bit time to figure this out. I think this is the 9. Oh, okay. Now it makes more sense. And the next one is 8 going like that. Yeah. This still doesn't. Okay. Let me try 9 over here. And 9 over. So now need to take a look at 10. 10, okay. So this makes sense now, right? And then we have another one that is 11. We went backwards in this one. This one needs to be 11 because you need to be higher. So let me try to. This was 10. And that is 9. This is 9. This should be 10 again. And this should be 11. Okay, that should be 11. Once we drop them. So the 11 actually goes like this. Okay, that's your 11. And 10 would go something like this. Yeah. Something happened here that was, you actually have another contour somewhere here. Okay, and then go up here. All right. So we're missing a contour somewhere over here. And yeah, then there's another 9 goes sort of around here. No, that's 9 goes here. And then comes up that way. And then goes around there and then comes down to up. Oh my goodness. I think, sorry, because your direction is a little different from others. Goodness, I'm sorry. Got confused here just because we're actually starting a swale now. Better go from one contour to the other. So my apologies. Go too fast. Okay. So this is the higher side. Bear with me for a little bit. 11 doesn't go back. Sorry, this is the higher side. So 11, that's 11. 10, this is 10. That's higher side. little bit, a tiny little bit, maybe. We need to measure if that's 25. If it's larger than 25, we have a tiny little bit here. And then goes around and then come back and then goes here. That's your 10. All right. And our 9 goes like this. And come back here. That's that. And then 8. That's your 8. Yes. On this side, there's a tiny little bit of 09 here that forms a. We have a question? Are we? No, okay. I'm talking to others. Good. Okay, so these contours, they look good. 9 is correct. 8 is correct. Coming back here, yes, 7 is good. I think we need to remove some of the kind of leftover lines, just so we don't have confusion whether this is a contour line or not. So would you like me to finish the rest of the contours? Or do you think we're good to move forward to retention? Okay. Okay. So let's talk about the retention area. We talked about this one. And we were at this. This one is not receiving a lot of water. Okay, we're not receiving a lot of water because there's only this tiny little bit. This is the tiny little bit of sort of drainage area that is receiving. Okay, that's too small. Unless you want to put a trench drain somewhere and collect water from elsewhere, this is not performing very effectively in terms of retention area. So recommendation would be, we could have a trench drain along this curb, which essentially will collect all the water, almost all the water from this portion of the plaza, right? And then your retention can be here because that empties out from here. Okay. So that would be more useful than the one, because the one that you currently design is on the high side and it's not collecting much water. For this one, we're at a relatively low. This one is more, I would say it's more effective because you can see it's kind of collecting all the way up here. That's how much water it's collecting. Not all of them. If we see, do another perpendicular line here, that's how much water it's collecting. I would say it's significant. Okay, would say this one is worth doing. It's the same concept. You need to look at kind of well, let me zoom into that location. You need to look at where water comes in. Water comes in from here, right? This is the higher side of the retention area. This is the lower side, meaning this, if it will spill out, it comes out from here. So the first thing, as I explained to Pega and a few others, you need to understand the elevation here, which is slightly below 10. Okay, you have 10 here, slightly below 10, and here is about 9.4. All right, so basically we're dealing with a situation where we come in at 9.9, for instance, 9.9, water comes out at 9.4. And I would say we're trying, I would still advise that we have a wall here, you know, have a wall around the lower side and use the 9.9 as the reference for water flow and the highest, right? So our RDI could be 9.4, right? LP could be 0.8, 0.4. Okay, and then the top of the curve, no, top of the wall actually. Top of wall here can be the same as this, or it can be a little higher if you want to make it a sitting wall, right? You could calculate the plaza elevation. You can add 1.8 to that, 1.5, so that you have a sitting wall. Does that make sense? So it depends on whether or not you just want to keep it at 9.9 as the entrance level, or you want to make it higher to make it more multifunctional. So currently what you have is too low. Okay, it's not based on the plaza elevation, and we need to return to knowing the elevation on the plaza where water comes in and water possibly will spill out, and you don't want them to spill out, so you build a sitting wall there. That makes sense? Okay, good. Good. And next, you have one of that here. So I wouldn't necessarily build another one here because it's pretty close to the one that you have to have, right? Which is outside of the swale. Okay. I probably would move this up a bit and have a bigger one. So let's see, something here in between those, and another one over here, and then a big one over here. Given if we design one over here, your curb cut is 7.4, seems pretty reasonable. RDI 7, LP 6.5, 07 contour. Yes, you have an 07 contour. And again, I wouldn't think you needed a 08 contour. Your high point would be between your 07 and the other 07 outside. Okay, so you do not need the 08, but you need to know where your 07 is. Your 07 is to connect back over here. This is a closed 07. You have another 07 coming out and then getting to the wall. Your 09 would probably hit the wall like that. So so that one, your 08 will stop here and then come out actually in between that one, and then you have your 07, doing something like this. So this one, the retention here will be between excuse me, your 07. Let me get rid of that one first. But your high point needs to be between these two 07. Okay. All right. This one, the same idea, 8.4, yeah, same idea. Do remember that this is a grading plan. You are drawing the contours of the retention, so it should not conflict with all the other contours. Okay, so if your 09 was here and your retention is over here, these contours, they cannot intersect with each other. Okay, and this will need to be changed once you actually learn about the divergence swell. So I wouldn't spend much. I would actually delete this one for now or turn it off, because you will need to change it, because right now your clean water is all draining into your retention area. Okay, so basically, it actually requires you to have a retention, have a divergence swell, and then this is kind of tucked in inside the divergence swell. And honestly, I didn't even drew correctly the divergence swell. because you will need to make sure that this wraps up like this. So water coming down from the slope gets into this swell instead of going into your retention system. Okay, so I would actually turn off what you have for this area for now, because they might be graded during exercise 4 and they're not correct. Okay. So I see you have a few other questions. Does anything happen in this area? Well, honestly, this is in the high side. You're not receiving any water naturally, but if you have a trench drain somewhere, you could direct it. Yeah, it's actually, it's all on the high side. So water is really not draining. There's a little bit of water draining from this side of the ridge. Only this little part will drain inside here. So yes, you could design a few retention depending on how much water, how much drainage area this is. Yeah, basically all water all drain that way, and a little bit draining into here, a little bit draining into there. So you probably need 2. Okay, you need 2 retention in this area. Does that make sense? Yeah, okay. So your other spots, I don't see spots missing. I see an extra contour and I see one of the spot miscalculated. Always remember when you have a CC, you also have a TC. Okay, top of the curve needs to be there. Okay. How many other retention areas you would need? Okay, that's an important question. You definitely need something here at the end. It's good to have something here. It's good to have things over here because you start having water draining into it. So this is also, yeah, this is also necessary because you have some water draining here. This is good. We talked about it. This is good. You definitely need something at the end of the swell here. You have one here for this drainage area, and you have one more for this portion. So 2 of them here, and a few over here. So starting from this, it all drains down here. That is right. You have a little bit draining into it, into this vegetated area here. So I would say one more here. That's only a small area. I would move this down a little bit. And then have another in here. So on this side, at least 3 along this side. So that's about the number of retention area you would need. Okay. Well, definitely for the roof and for the back plaza, you still have to put these in. I think that's. How would you do a retention area in between the parking lots? How would it connect to the contours? Do you mean these areas? Yeah, well, it's the same. It is the same thing, okay? Like I explained just now, you seem to have a really spacious, you would do the retention in between these contours. Okay, if you need more space, you could change the shape of these contours as long as you keep the connection point, because those are determined by the parking lot. But what else happens inside is it's the same as the other ones. Okay, you determine where the curb cut is for this one, because it's all draining in that way. You would put the curb cut lower, right? Curb cut lower so it receives more water. So this might be 8.6, something like that. And then your, you don't need a DI in this case. You don't need an RDI or a DI because we're not the last in the chain, but this one needs, let's see, actually, this is the lowest point, or I take it back. So that point still can drain along the curve to this point. So I would, for this one, okay, I would put the curb cut directly there, right? You can have a DI or an RDI, but use this. This seems to be about 8.5. Use this as the reference elevation for determining your RDI elevation or a DI elevation. And then water level will be, 0.5 below that, or if you use it as a DI, then it's exactly at the DI level, okay? And then you kind of define your LP. But, what needs to be remembered is that as long as I keep these two, I can modify the contours of that one. I can modify the shape of this contour, and then the contour that is happening inside can wrap around and form something like this. Okay, so that contour, it's likely 1109. And you have an HP between the two 1109, and that's it. Okay. All right, so that is the last question. Anything else? We're good. Okay. So next we have, I think this is Emma. Okay.
Before we get started, is this being recorded?
It is.
Thank you.
Yeah, so all my breakout room recordings are converted right after we conclude the meeting, and I upload them to YouTube, and the link is all on Canvas. Okay,
Good.
so you should be able to access it just as easily as the media gallery. Okay, so this one, you have a DI, then you don't need an RDI. Either one, okay? Seems your RDI is too high, or at least something here. Well, I think it's your CC and TC calculation are off. If this is the 103 contour, which seems a bit close to your 104, is your parking lot slope a little bit?
It's 3.33%.
Okay, so it's 30 feet apart?
Yes.
Okay, 30, yes, 30 feet apart. Let's see. It feels like you have a 102 contour here. Yeah, definitely you do, because, well, let me change the color so that we are not. Based on the distance, based on your contour spacing, I would say you have a 102 contour here. And your curb cut calculation is actually makes sense. Would be 1101.58. That is pretty reasonable. So that means your RDI is not correct, right? So again, if your BC/DC is correct, you do not need an RDI. So we'll cross that out. Your water level is a foot, so that is correct. LP is correct. Okay, LP is correct. And then your contour here is 110. There's a closed 1102 here. And your contour is actually 1101. There's a 1101 contour here. I believe so. Yes. 1101 contour. And let's see what other contours you have. So that's 03. That is 03. 02 is a closed one. And I need to find another 02. You are pretty low here. I mean, in terms of contours, and you don't have a 03. 02 is somewhere there. That is too flat. Okay, let me try to zoom out because I think we have a elevation issue here. We're getting too low. So if my original 3 is here, and if I keep offsetting at, well, even if I decrease the 2, my 2 needs to be here. Which means I need to attach the 2 over here. And I need to have another 2. So yes. So I know this is a little too late to change design, but you can kind of sense I'm getting a little bit too low and then I need to climb up. So if we are at 105 here, it will be super because I am just about the right slope, getting down to the kind of original, the natural topography of 105, right? So this means I need to create the 3 and 4 and 5 and even 2 here, just so this area wouldn't get too flat. Now your original 103 is here, meaning that even if we keep a 2% slope, your O2 have to be here, otherwise this area won't drain. Okay, unless you create a huge pond here, then you would eliminate that problem. All right, you could do that. So then your 2 would be just right there. That is your 3. Your 2 is over here. But your pond needs to be pretty big. You can kind of see. Yeah. So
do you think it would run roughly the entire length of that parking lot?
Run the entire length. Yeah, our goal is for the distance between O3 and your O2 not to exceed 50 feet.
Oh, okay.
Yeah. So you can see from this point on, it's too big, right? I'm pretending the 1103 was in its original location so that you can see kind of the distance we have, especially once we get to here. We're pretty flat. So you would need to create a big pond here, which is not a bad idea because all the water it's getting down there anyway, right? Or split these two. Okay, better solution would be split this two. You have one here and then one there, so that your your contour here, once you get to 2, your 2 is over here. I need to make sure that this is not too flat. Kind of makes sense? Yeah, I think you should be able to do it. You should be able to do it with just by creating 2 retention area there. All right.
Create those 2 retention areas.
Mhm.
What would the contour be that runs on the retention area?
So for instance, this one, you get down to 1101.66 at the BC and /DC level. So your contour will be 1101 there.
Okay.
Because your LP is below 1101. And your curb cut is above 1101.
Okay.
So that's why your contour there will be 1101. Here, I think it's gonna be 102. So it just depends on what your elevation of the curb cut is. Okay. So to recap, you are missing a contour here, and RDI level is too high. BC and DI is good. You do not need the RDI. LP level is good. Contour number is wrong. It needs to be 101. Okay. And so that means you need another 102 between your 101 and 103. Okay. And no, the other one you would just based on the calculation of the curb cut. Okay, so that is the first one. Take a look at the other ones. So this is, this is worthwhile, because, it has a pretty good, contributing area and no curb cuts. We're on the plaza, okay? We're on the plaza. And this is about 105.75. RDI makes sense. LP makes sense. And I'm not sure where the 107.5 comes from. I think it's probably leftover. Or is it an HP? Yeah, that's HP.
Oh, those are for the sitting wall, like the.
Okay,
bench around
good.
the back.
Yeah, then use B1 T wall.
Okay.
Yeah, because it's essentially a sitting wall, right? So that's good. And I'm still a little confused as, what the HP, is it inside? Well, you wouldn't need an HP, right? If it's HP, this is the top of the wall. Okay, here you do need top of wall and bottom of wall. Bottom wall will be around 5.75 as well. Okay. And you can kind of calculate how tall actually the wall is and what you can use, that wall for. I am suspecting that we're missing a contour in this. No. Well, your LP is 105, so you have a 105 contour in it. Yeah. Okay. Good. So in this case, we are if that is the 105 contour, I'm not sure. I think your wall, part of the wall would not necessarily overlap with the 105 contour. You need to think about the spatial relationship between the wall and the 105 contour. The 105 might be smaller than the scope of your retention area. Okay?
Okay.
Yeah, just think a little bit about how exactly it would look like. Right. I would reduce the size of the original contour numbers because it's a little overwhelming to see these numbers here.
Mhm.
Okay, it's gonna get pretty cluttered. Okay. Yeah, you're right. There's no curve there, so you don't need a curb cut, but you need to know the elevation at the entrance there. Okay,
So, but I would keep that spot elevation.
Yeah,
just
get rid of the
really
CC.
good CC.
right,
Okay.
correct. Okay, the next one, you wouldn't necessarily, well, that is not the lowest point. So the point that is the lowest is actually this one. Here is the lowest point. Okay, so move that one here. And yeah, RDI works. This would be, I'm trying to see, that's 06, 5 point, probably 5.4 or 3. And yeah, again, we're double using DI and RDI. We do not need both of them. You need one of them. Suppose this is the correct BC/DI elevations. That's reasonable. And RDI cannot be higher. Okay, just get rid of the RDI would be good. And LP works. And this contour is actually 5. Does that make sense? Because LP is for below 5. So this is the 5 contour.
If I put my curb cut where you put the little X, would I use like a perforated pipe then to get it to that retention system?
I would actually suggest that okay, you have a little bit of a plaza over here.
Yes.
Honestly, folks would not stand there because, kind of there's very limited space and it's angle space, right? So I honestly would just modify the shape of the pavement and do a little bit of curving here probably. you know, just do this.
Okay.
And then it can come out. It's a less expensive option. Yeah, contour number, I believe the contour number was a little messed up before. No, actually, if you have 1106 here, you would have another 1106 coming out of here. Does that make sense? So this is the 1106.
Yes.
Yeah, and then there is a 1106 that's supposed to come out and then come here.
Yeah, it runs down the side of the plaza
You could, yeah, it
currently. I don't know if that's right though.
so it needs to attach to this point, right? You could run this way. You could run this way, that's okay. But it also could run this way. And if this entrance, we'll just use the original one. If this entrance is 5.75, if you wrap this inside, that is a 5 contour, you have a 6 contour, you need another 6. Okay. If that's the case, we actually need to run it outside like this. And then let's see. Yeah, this requires you to create a 1, a 5, and then a 6, which is if this is the 6, yeah, it does need to be wrapped inside. Okay. We'll just wrap it inside, and this is the 5, and this one will be inside here. We will have a 5 contour and another 6 contour. So you need another, let me just draw the 5 inside and 6 here, and your high point of swell, not high point of swell, but high point will be between these 6s. Yeah, that's how you do this one. But once you get down to here, you're actually below 6, you're at 5. So then in that case, most likely it's gonna do this, and then you have another one down here, and then your high point will be between the 5 and the 5.
Okay.
Yeah. So recap, redo this one using this as the entrance. Okay, the inflow, okay,
Mhm.
and that is below 6. That is 5 point something, and then add this contour back in. Goes like this, and this thing would be tucked in between the 6 and the 5.
Okay.
Yeah.
That makes sense.
Okay, good.
So in general, I only need 1 entrance. I don't need to have 2.
The curb cuts?
Yeah.
You don't need to.
Okay.
Yeah, and in this, oh, you mean, okay. The design would be, if you have a DI, you would need 2.
Okay.
If you have an RDI, you just need 1.
So does that mean that if I just do the one over there, I'll have an RDI instead?
You could,
Oh,
yeah. Yeah, it just prevents cutting too, because space is quite limited here. Yeah. All right. Well, I think that's all the questions you listed. Let's see. In general, doesn't matter. It does matter. You wouldn't want to find, you know, the most efficient green space that's receiving more water. It definitely needs to be placed at the corner like this is absolutely necessary because, you know, otherwise there's nowhere for the water to go. No, do only the ones that are at the end of the chain, where if you don't have an RDI or a DI, there's nowhere else for water to go. That's where you need an RDI or a DI.
okay.
Okay, everything, every place else, if water can keep flowing downstream, then you do not need them. All right. So for instance, I would say, you know, it's good you have all these, but you wouldn't draw later on. You put it in, these will be between 2 contours. It's not a big one. Does that make sense?
Yeah.
So you would have 3. actually even 4 if you want to. But they will be between these contours. Again, as I explained just to Maddie, I believe, you know, you could change these contour shape as long as they are connecting between these two fixed points. You could modify the shape of them to accommodate your bioretention. All right. So you definitely need this and that. Something here would be good. Yes, you have it. And in here you need one more because this is the swell here. Yes to this. And later on 3, probably 3 over here. And this is good to have 1 too, because some water is draining this way. So along this line, a couple here, 1 more here, because you have room here, right? But these are places you would create retention. Don't forget the roof and the back plaza. Okay, that's it. Good,
Sounds good. Thank you
good,
very
good.
much.
All right. All right, check the time. Okay, we still have time. Calvin? Let's take a look here. I'd say, you know, you need to move it to the end of the swell. You know, if my swell goes like this is where I cut it out, right? Where I cut the curb. In terms of elevation, you have 1104.40, 3.40, good. All these are good. And your contour is at 1104, correct? And you have a 104 contour. Well, your 104 contour needs to be moved. All right. So we have to keep moving some of the contours there. So your 04 cannot conflict with your 05. Okay. Once we I am a little suspicious in terms of where your 105 is. It seems like if my swell line is correct, if I try again and try to extend it to a sort of precise, yeah. Somehow it's a little. Can you see when I'm having difficulty identifying where the swell is? You try again. So here, from here to there. Now it does seem correct. Okay, so some of your LPS is a little off. Does that make sense? Check. You do need to have the swell line in your final plan, so you might as well just add it. And now it does look kind of reasonable in terms of where your 105 is, but I would not put the, I would basically do this. So this is my 1105, kind of coming back here, and I will only have this much space. I can keep pushing. You can try to push a little bit here and see if you can get a little bit more room. But not much. I would say not much. So you can probably, you know, the most room you would have is for 105. So try keep pushing a little bit, and then your retention will be in here. Okay, that's your retention. I think you understand all the other relationships, so I'm not concerned about that. But originally your 04 was conflicting with your 05, and that is not correct. Okay. And the other way, if you want to, you can close this up. So 05 stays here, and your 05 can, you know, keep coming down like this. And then this can be a little bit bigger if you need more room. Does that make sense? Okay, good. So that is the first one. And let's take a look at this. your slope arrow, it's not perpendicular to your contours, okay? That could be changed later. We're putting in retention in between. Should I have the retention area be the entire vegetated space? I think what you have, it's pretty good. Basically, your this is your how your plaza starts, right? Is that right? So everything in between is green? Yeah, so that's good. You are, but I'm not exactly sure about, splitting all that much. If the entrance are at relatively the same elevation, I think you're okay. Sort of merging, at least merge this one and having 2 here instead of 3. Well, but that's not sort of required change. It's not like things are done wrong. It's I feel a little more work than necessary, especially in this area. Okay, so for this one, you have I'm trying to understand the logic here. You have a 7 contour here, and the LP is somehow outside, and that should not be the case. But your RDI seems reasonable. LP seems reasonable. And your HP, we're missing a contour number here. So you would have a 7 oh no, you actually have a 6 contour. So the HP is a bit too high there. You have to have a 7 contour between your H contour and your HP equals to 7.25. Does that make sense? Yeah, so I'm not convinced that your HP needs to be that high. And I honestly, let's see. Calculate your curb here. Okay, calculate your curb here. You might not need an HP if the curb is high enough. For basically, if so, we're coming down here, and we're coming down to a curb. Right, this curb is that curb. This is where your water is coming in. And if your water is low enough, it won't flow out of the curb anyway, then you don't necessarily need a high area here. So we're at about 1106.4 for your RDI. So let's see if this is in the RDI and this is the bottom. The bottom is 1105.6. And I need to know the curb, okay? The lowest curb is over here. I need to know the lowest curb elevation here in order to judge if this curb overall is high enough. Does that make sense? Yeah, so calculate that one, and then so this is about midway between 07, so this is about 106.5. Yeah, I agree. This is a little low, a little too low. So yes, you need a berm in between, because as I mentioned, your RDI is here and your curb is only 106.50. So it's a little, we need a little bit more. So you need a little bit more berm here, but it's not high as 107.25. Does that make sense? Yeah, you need for it to be 106.9, something like that. Okay, so you wouldn't have a 7 contour, you would have a 6 contour. Yeah.
I put in like the low points outside of the bioretention because I thought they were like the substitute for like the curb cut to show like that's where the water goes in. So
Well, because you're changing material here, right?
yeah,
So you need these, and you don't need that if this is a one arc, one curve. You do not need them. You need that one, and that's good enough for indicating where So you need that one. So remove the LP and you're good.
Okay.
Okay, yeah, that's good. Yeah, and these later on you will add them. Okay, so that is a different design, and this is one of the first kind. So I'm glad to see the variety. For this area, I don't know why we would need a DI. I think there's something happening. Something with the contours are let's see. Because you wouldn't necessarily move your swell line once you dropped them. Let's see. Okay. So that is the 07. If I come down here, that feels like the previous one. And then once it's dropped, this is the other one. Yeah, something about this 07 contour here doesn't seem correct to me. So I'm just trying to see if that's a valid concern. Do that, and do that, and do this. That's correct. Oh, these are good. And this portion. This portion is actually gone, right? Yeah, we don't have anything. This portion wouldn't be able to be offset anymore. So you only have this. Am I right?
Yeah.
Yeah, I think that's it. I think that's it. And then your 6 is good. So 7 should only be this part and that part. Okay, we don't have another 7 over here. Yeah, you can kind of start see the 107 and 06 contour kind of conflicting with each other. Yeah. Okay. So all right. Going back to that area. That's the reason why, your DI wouldn't be there. Your swell would always be along this line. So you would have something, well, that's right by the ADA parking lot. Not a great thing. Let's see. If you can move the IDA here, I would move it here. Yeah, it's because you can see this is where the water just will be all draining down here. You would have a curb cut over here. So move those over and recalculate starting from this point. And let's see if this one works okay. So yeah, the elevation seems good, LP seems good. HP again, I think it's too high. You would have a 106 contour instead of 07, okay? Yeah, the contour number is correct, but the HP is not. And for this one, 06.62. Well, you wouldn't need an RDI here. If you're not doing an RDI here, then you wouldn't have more of a reason to create an RDI upstream. I would get rid of the RDI altogether, and just let it continue to go down to here where you would have a DI. All right. Same thing. I would say the same thing. You have an 07. Yeah, now you have an 07 now for this portion. So you have a 6 contour and a 7. If it's between 6 and 7, you wouldn't necessarily need a high point. Does that make sense? Yeah, unless you want to create another 7 in between, because you have a 6, then you have an HP of 7.5, then you're bound to have another 7 in between them. That's an extra 7. I don't think you need to create that 7 because on the other side is already higher. Yeah, so you don't need that HP. Okay. Well, whenever you got a little bit confused, you could quickly sketch like a cross section, then you'll understand it. So those are the 3. Anything else you wanted me to go through?
I think that's all.
Okay, good. Next we have Winnie. All right. So your first question is about representation. From this scale, I'd say your contour number can be a bit larger. Your spot elevation is actually at a good size. The drawing later on will become very cluttered. And, you know, for instance, one thing that could be improved is the parking stalls. They should be of the least, okay? They should be of the least, kind of the weakest line weight and color. So you basically, by changing that, immediately you would have a much less cluttered parking lot, because the information that's going to be jumping out will be the contours and the spot elevations. Okay, so the parking stalls, the painting, they should be much lighter. Okay, and try to avoid for now for placing the spot elevations right on the curb. You can do the masking as your final step. So for now, place them kind of relatively in an empty area using leader lines. As a final step, do the masking of the text, so that you do not have too much overlapping information. The other thing is you do not have to align, you could, but you do not have to align the contour number with your contours. You can make them parallel to your page. Okay, that will also actually make it a little bit more readable. And let's take a look at the retention area. You have 1 here. You have a DI. That's good. And a 5.85. You don't have much depth here, okay? I would encourage you to move the LP down to 4.85 so that you have 1 feet deep retention. And honestly, you need a lot more area here. Reason being, all of the water on this side is actually draining towards this DI. So what you could do is, if you have more space, create 1 more here. And then enlarge this one that you currently have. Okay, make this bigger. Utilizing that corner. Okay, this corner space. So in terms of the elevations, this looks too high. You could put it down. 106 contours, correct. And you have another 106. That's correct. Let's see. Yeah, 06 wrapping around. Okay. Well, let's see. Double check. If this is 05, yeah, that's a close contour. That's correct. Okay. So the only thing I would say, move that lower, and then make this bigger. You're missing 1 more. Well, of course, you haven't done all of them. Just a reminder, you need 1 more here because this is also the lowest point. The water won't be able to flow. if we don't have a curb cut here and we can use it either RDI or DI for that one. So generation relationship look good. So for this one, we are off the plaza. You need an RDI, that's correct. You do not need a curb cut because this is the edge of the plaza. Okay, there is no curb there. I would modify the plaza design here just because there's no way people will be able to stand there. So you can make a curb here, making a perpendicular angle there. So basically water just sheet flow in, right? Sheet flow in, and you would calculate the elevation along this line. It's about 110,615, which is, the calculation looks good. I think there is a line that is confusing. You probably have one extra line. This one and that one. This seems like the edge of the plaza. Not sure what this line is. Okay, so that one, if that is 1106.15, your RDI, I would put the RDI a little bit lower than the edge of the plaza. Okay, 5.85, something like that. And you have a low point. Well, water is exceeding 1 foot, so that is a little too low. You raise it to, let's see, did I do the, oh no. Okay, let me record it so that I know. RDI would be 8.85, okay? And then no, LP would be 4.85. So you would have a 1105 contour and then 1106 contour. Two contours there. Yeah, I believe that's right. And then you have a 106 contour over on the other side, and then you have HP. HP is correct. It's correct. Okay, HP is right. HP is right. Questions about this one? We're good? Okay, good. All right, we'll move forward to this one. This one, you have curb cut. Well, this curb cut is not receiving any water. This curb cut is not receiving any water. Reason being, you can see on this side, every water kind of flows that way. Does that make sense? So we do not have a curb cut over here. But that kind of raises the question, where would water go from this side? You do need to cut a hole in this case, okay? We'll need to find, if water keeps flowing down, honestly, eventually it comes down here, but you would want to try to capture it. Well, no, sorry, my bad. This is the lowest point. That's the lowest point, right? You need a hole here, which is not a difficult thing to do. You have a big plaza. I would say do a retention area somewhere here. Cut it out, and the water will just go inside there. Okay, and that is absolutely necessary, just because water will not have anywhere to go if you don't have the curb cut. For this portion, I would put the curb cut a little bit down, somewhere here, not a lot, because you're not receiving much water with this retention either. But what you can do is to add a trench drain somewhere here, and that trench drain goes into this. Okay, just because if you open up this, you're only treating this much water, which is not very effective, right? So if you do a trench drain, you would use the trench drain here to collect all the water upstream here. It's basically all this goes into the trench drain. Okay, and even the trenching can be a little bit lower, okay? And you can cover a little bit more area for that. And then from that point on, you direct the water into your green, okay? All right, so that is this design. Because of that, all the elevation will change, so we won't be able to use this example to criticize the design anymore. DI here is at the wrong elevation. Okay, DI needs to be somewhere here because this is the lowest point. You look for the largest distance from the curve to the 118 contour, and that's the lowest point, and the DI needs to be here. All right. Okay. So yeah, we addressed that one. Curb cuts. We talked about the curb cuts. Yeah, it will be good if you have a lot of retention in this middle, and then you have one more here, one more there. We said we need to add one more here, and we need retention here, and retention at the end of the swale, and a couple along the way here for the roadway. Well, not that one, not the first one. Everything drains here, so you're right. Your retention needs to be in this area. That's good. That's your retention. From this side on, you probably just need two. Okay, so if you added the train drain, I wouldn't think that you need this one because much of the upstream is actually treated, and then the rest could be treated by that. So if you have a trench drain over here, I would say you do not need anything else on this side, but that one is still necessary. Okay, anything else? In the middle of the parking lot? Well, it's the same principle. Well, you would have one between two contours. So if you want to create one between this one and that one, it could be just one big one, or you can split it into two. You know, I would probably do one here and do one there. Let me just move that one. You don't need that big though, because, well, if I am using that one, then this is my retention, kind of the catchment area, and you do like a 1/12, right? And 1/12 might be just that big, and that's enough. But in your case, you could make it larger because you have the room. And then I would say the other one would be somewhere here, and somewhere here. You could modify this shape so that you have a bit of a larger area. And I would say this one, you can be kind of more free in terms of, no, you really don't need to modify the 1107 just because you have so much area to treat this much drainage area. Okay. Yeah, just remember one between each sets of contour. Okay. All right. I think we have 3 more. Vincent? Okay. Let's take a look at this one. All right, 1108 contour 7.78. And then we have an RDI, that's good. LP, great. You have a 7 contour and an 8 contour, and out of that is the 8 contour. No, good. Who is here? Huh? Someone is, oh, maybe just showed up. Okay. So that's all good. Don't forget though, this contour seems to be too close. Okay. And you need to keep modify that. All right. So that's that.
Like,
This one. And yes, you need to grade this little bioretention inside. So we have went through a couple examples about plaza, how to do plaza. Basically, you need a wall, right? At the lower end so that it doesn't flow out. Okay. So this one, it seems to me a little too low. Reason being, you need to calculate the elevation here. The elevation here seems to be 7.5. And if that's the case, your RDI is a little bit too low. It's 1 feet below the 7.5. Let's make it just 7. RDI equals to 7. Then your LPS will be 6. And then you would have a 6 contour and a 7 contour. That's right. And then your HP is between those two. So those are good. It's just a little bit too low. So the kind of depression will be a little bit too deep. In terms of aesthetics, that's a little unpreferred. You know, people don't like to see deep holes. Okay, so that's that. Okay, let's take a look at this one. For this one, bigger picture. Well, you have this good retention area. You have one more here. You do need one more down here, and you marked it out, so that's great. So for this one, curb cut, good. RDI, good. LP, good. Well, I would basically just do a 0.5, or for the LP, I do a 0.59 because I just want to keep the water depth to 1 foot. All right. You have 1107 and then 1108. All sounds good. So for this one, all sounds good. Okay. And yeah, the bioretention you have completed are pretty good. How does a swell interact with bioretention? This is the end of the swell. The way you presented it is completely fine. All right. You do not need the swell to continue. So the way you did it, it's good. We don't need to modify anything. You do not need an LPS though. Basically your swell ended when it entered the retention. So you do not want the swell to continue, reason being you want the retention to be relatively flat. So you just get rid of the LPS. That's good. Okay. If you want to, you can mark this one as the LPS. All right, just to show the TAs that yeah, I have the low point of my swell, right? Okay. The wall spot elevation's correct. Let's take a look. So yeah, 109. Well, we're missing a 98 contour. Okay, we're missing a 98 contour here. You have a 6. Well, I would say both. We don't have 98. We don't have 97. We need both of those contours. And let's see. That's the 5. That's the 6. That works. Here we have a 93%, 97.6. That's the 6 contour. The B wall works. Although your wall can end a little bit sooner, but that's okay. You do not need 2 B walls. You just need 1 B wall. And you basically have 1 cross and you have 2 numbers, right? T wall and B wall. That's what you need for there. Same thing over there, okay? do not need two B walls.
Yeah.
And I'm not sure why it's like, no, approximately 1096. That's probably what you want to say, okay, I haven't calculated it. That was an estimate. That's probably how you labeled it. Okay, so that's about the walls. And definitely, we need to complete the contours of the ramp later on, not just yet. Okay, so that is that. Do you mean the line width for the bioretention? You basically use the exact same line width as whenever as the contours. It's not a special system, okay? If it's a minor contour, use the minor contour line weight. If the major one, use the major one. It's not a separate system. The whole thing is a grading plan, and there's no kind of special contours for the retention, right? Okay, anything else you want to ask?
For the on the bus drop off,
Mhm.
that PI over there,
Okay,
can I leave it as a PI or when the bar retention? Because on
yeah,
that's the PI is like path for people to walk on.
yeah. That's why you need a trench drain over there. Yeah. If you observed Tuesdays, I don't see many, I haven't seen an example in today's review, but on Tuesday, one of the first examples I reviewed had a trench drain. But I really quickly go through is that, again, you would want to draw a cross section. And you have a curb. You have a curb here, but this is a sidewalk, right? And the curb cut is somewhere here. And then you need a trench underneath. So the water flows in here. Right? Water flows in here. You cut it out, and then water flows in here, and then it goes out on the other side of the sidewalk. So this is the top where people walk, and this is the bottom of the trench drain that water comes out. So essentially, if there's no sidewalk, you use this elevation as the sort of the top of the flow and use that to define your RDI. But instead, in this case, you need to minus 0.5 just to account for the depth of the trench drain. Okay, so you calculate, use the same 2% slope of the sidewalk down to do this one. So basically this is based on calculation of the curb cut, but then you drop 0.5 at the bottom of the trench drain. So essentially you would draw a trench drain somewhere here, right? And then here you need to indicate BED, bottom of trench drain, and equals to what? And then the well, here it wouldn't be a DI anymore. It would just be a CC. Okay, because you cut it, but now once in this situation, you need to use an RDI equals to BTD minus 0.5. Make sense? Yeah, so the water comes out of the BTD and your RDI will be below that BTD. Okay. Good. Again, you can review the Tuesday's recording, one of the first review, deal with that. Okay. All right. Great. Good question. Okay. I think the next one is Brianna. Okay. All right. For this one, I would cut it down here because the corner is the lowest location. Okay, this is the lowest. We need to cut it down here, and all the calculation would be based on this curb cut slash, well, you use an RDI, so you don't need to use a DI there. Suppose we're using this elevation as a way to assess the design here. If this is 0.6, your RDI 0.5, LP 0.5, L1107, 08, all these make sense. All right, all these make sense, but your curb cut needs to be moved down to the corner, okay? Yeah, you need a DI here, which is good. Okay. Okay, I'll zoom out and see the other ones. So for this one, curb cut, you seem to, yeah, you changed the direction of your, good. Well, problem is that your curb cut here is not receiving much water, all right? You are receiving a little bit, but your curb cut, you want to put it downstream. So, for instance, if I do perpendicular to the contour on this side, you know, I can catch up to somewhere here. So I would put my curb cut somewhere there. Does that make sense? Yeah, put the curb cut over there. If the curb cut is over here, I think you understand, you know, kind of the whole elevation sort of relationships between these things. Yeah, RDI, LP, 08, 09, these all make sense. Okay, all these make sense. Just move the curb cut to a different location. I would add something over here as well. Reason being, you know, water is still draining this way, right? Water is draining this way. You want this portion to be able to receive some water as well. And because these curb cuts are at about the same elevation, you don't need to separate them. You just, you know, that's one big retention in the middle. Okay. That does require you to change some of your contours, but I think you understand the relationships. You just need to change the shape of the contours and open up another curve cut. All right. So that's the second one. Third one. 110. Yeah, I think you have the same issue where the water here is too low. All right. We went through the plaza example. So you would use this elevation, right? That is about 8.6 to determine the RDI. So I would raise this to 8.1, RDI to 8.1, and then your LP will be 7.1. Then you wouldn't have a pretty deep hole in your plaza. And you know, you need to know what the elevation here is so that you know how much of a wall you would put at the lower end. Does that kind of make sense? Yeah, cool. All right. So this is overall a little too low. And yeah, you do not need HP. For this solution, you would have B wall and T wall for your sitting wall at the lower side of the retention. Okay. And that's that. You wrote some questions here. Should the bioretention be in the swells? Yes, they should, because that's the most effective way for them to collect water. In the swells, it's not online just because you only have one here, right? You only have one here in this chain, and water would only the excess water will actually get into the REI. It doesn't really make it all kind of online. It doesn't go through, right? The design we had, the water doesn't really go through, kind of push through and then continue to downstream because of your RDI and because of that sitting wall that you're designing. Okay, so it's not online system. Keep going. How do you make a berm? We went through that. And how do you know where the push contour make the curb 6 inches? Does pushing them to accommodate barrier change? It doesn't change the curb height. I'm not exactly sure which portion you're referring to. Can you clarify the curb question?
Well, like, when you like initially push the parking lot, it's like
Mhm.
they're even distances away when it pops out, but then like to make room for it, you have to kind of push it away that like where you did before.
Right. You push the contours within the green area, definitely, but you do not change how those two contours kind of connect to the parking lot contour. So I kind of understand your question here. Yes, it comes up here and these cannot change. What's inside, you could change however you want, right? If you need more room here to create a huge retention, you could push these, but you do not change these because the curb, top of the curb there is fixed. Yeah, so the location of these connecting points are not flexible, but what can be modified, what's the things, you know, how exactly these contours go, you can do whatever you want. Yeah, yeah. Okay, so that's that question. Anything else? Good. Yeah, if you have observed the reviews, most of the challenges have been addressed. Okay. So, Martina. Yeah, I know. Thanks for sticking to the end. All right, you did quite a few. Let's take a look at each type. You wouldn't necessarily need so many RDIs, okay? You need one RDI because this is essentially one unit. And, you know, you need a curb cut. Oh, sorry. You need a curb cut over here. If you have an RDI, you just need a curb cut at the core, right? If you use a DI, then you have two curb cuts and a DI in the middle. Does that make sense? So for this corner, there is two kinds of designs, right? A DI in the middle and then two curb cuts. The reason being everything would most of the water will go inside there, just a tiny little bit of water that is not when this is full and that is full, this little thing, all the water the rest of the water will go inside the DI, okay? If you have a RDI, you just need to cut this open and water will keep flowing down, but everything that is exceeding the RDI's height will get into the RDI. Does that make sense? Yeah, so you do not need two RDIs kind of, and then a curb cut, which the curb cut, I'm not sure where it is, right? I think your intention was to put it here, but that's not the right combination of the systems. Okay. All right, so we have a curb cut at 7.34. That's correct. That's correct. This is good, and that is good. Everything else works. Just not the RDI. So the correct way would be curb cut, DI. Or curb cut, DI. Okay? Oh, sorry, RDI. All right, that's that one. So for this one, 7.89. RDI works, LP work, contour work, and yeah, that's it. And I don't think we need to go through the other ones because you clearly understand how this is done. Let's look at this one. 6.45, good. 40. I would put it a little bit more, okay? I would at least 0.25 I would prefer to put it 0.5 down the CC. So LP, okay. And then this is the 1106 and HP all work. This all works. Any other ones that are of different type you want me to check?
Quick question about
Sure.
that little traffic signal you were just looking at.
Yeah, yeah.
So I put two trench drains at
Oh.
the two bioretentions that are like to the top right of it. So like through that
Here?
yeah.
Yeah.
And I added those since I submitted yesterday. But what I'm a little confused about is how to calculate
the like curve cut of that because like the 106 contour will wrap around that
Mhm.
circle,
Mhm.
but I'm not exactly sure.
Okay, so for these two, honestly, you need one at least kind of at the end of, at the lowest point here, right?
Yeah.
The calculation will be based on the distance to the 1106 contour here.
So will the 106 contour just wrap around the?
Yes, 1106 goes like this. Right? This is your 106, and this is your 106.
Okay, so it's just wrapping around the curve. It's not doing anything weird when it gets to that little.
Right. Yeah, so basically this would be 5.3, something like that here. Right? Yeah, the key thing here is actually you need a trench drain.
Yeah.
You
No,
need
I
to,
was just a little confused about like.
okay,
if the,
how to calculate it.
contour actually wraps around, but that
Yeah. Good, good, good.
I have some questions down by the not the plaza, so like the back patio.
Sure. Should I figure out the stairs? Yes, it's time to start figuring out the stairs because the stairs don't change anymore.
Yeah.
Yeah. So it seems like your stairs is over here.
Yeah.
Yeah, it's definitely time to do that. And your retaining wall should actually be here.
Okay.
Right? Between the stairs would be between the contour, the building and the retaining wall. And I'd say, you know, these contours, they all need to be changed.
Yes.
Yes, okay. Yeah, another thing is you want to try to avoid this to being too flat. Okay, your 106 might need to, 07 might need to be lower to avoid this area being too flat. Does that make sense?
Yeah.
Yeah. So basically you probably don't need to change these contours that much.
Yeah.
Yeah, because they originally they were like over here, right? So if that's the case, you only need to make sure that they hit the wall. So sort of, you know, diagonally.
Could I
Like,
just add like a retaining wall further down for like the 1097?
well,
Yeah.
your retaining wall will be extending that long.
Yeah.
Yeah,
And then add a retaining wall. Okay, I get what you're saying.
yeah. You basically, you do have a long wall. That's gonna be extending until you have probably 97. Like this. And then, yeah, the 97 probably needs to go like this, and then your 96 can, this portion I won't delete. Does it make sense?
Yeah.
Yeah. So drag it up a little bit, but all the others, no, keep where it was. Keep them where it was. Okay. Figure out the stairs. Yes, you do need to figure out the stairs there. I think these work. These are pretty big. If you have, well, I would say,
I have to double. It's because they're taking in the water from the patio and
Mhm.
from the roof. So I was gonna add like a line to say like the water from the roof kind of thing.
okay. That works. In that case, well, I think the assignment is a little bit, how you say, gives you a little bit less flexibility in terms of, I can see how, cutting off this will be great, right? But honestly, if that's done that way, you can see if I'm not doing anything else, this portion would not be treated. Does that make sense? This portion would not be treated if I'm not collecting water with other measures. Does it kind of make sense? Yeah, yeah. Yeah, so it kind of gives you disadvantage when we have to stick to the rubric. Yeah, so I'd say probably these don't need to be that big, but you would still have something kind of along the outside of the plaza. Yeah.
Could I just like, I could pull that one that I have on the outside and make it like longer, skinnier.
Yes, yes, yeah. Mhm. Yeah. Well, but obviously there are many, many ways to treat the whole thing.
Yeah.
And honestly, the sheet flow down, given that pretty big vegetative slope, it should not be a problem. You just disperse it into the vegetation. Yeah, but no, given that we're just trying to stick with the rubric.
Yeah.
That's why, I'd say not too big in the plaza, but, elongated skinny ones outside of the plaza. Okay, anything else?
I've done a lot of work on the computer here.
Okay,
Um,
you could get on Zoom if you have other questions.
okay.
Yeah.
Go over a little more on how I would make the stairs.
Oh, the stairs, so it's 10 feet elevation difference. You need 20 steps,
Okay.
right? Every 12 step, you need a landing. So you might just separate them into 10 steps and 10 steps, right? And then the top of the stairs would be determined by where, let's see. I'm just gonna zoom in so that I can do a little bit of a. So. If I start here, these elevation will be determined by my plaza. Does that make sense?
Yeah.
Yeah, so you basically use the contours that you had, and then you can determine where your end of the end of the stairs have a lot of flexibility, you have a lot of room to, you can put all the stairs somewhere here, or you can spread them out. And put the end of the steps somewhere here, and those lower, the bottom of the stairs will be determined by your lower plaza. That makes sense?
Yeah.
Yeah, so you know these elevations, right? And you know these have to drain, right? Though sort of this needs to be high and that is to be low. And that little space, you can design whichever way you drain. You can just drain it out this way with a a contour, kind of mini contours, and you can kind of imagine mini contours going in that. Like you can say 2% slope and calculate that way, right? Or you can do the slope just like this, that's okay too, right? You have these elevations, same or 0.5 below the BFFE, and then you can do a 2% slope, something like that, right? I would recommend something with a side slope, but we look at the kind of, you understand that the bottom stairs drain toward the bottom plaza, and that's good. At least 2% slope. So based on those, you could determine where your landing would be. Right? And then you have your top of the stairs, you have your bottom of the stairs, you have the number of the treads and the risers. It's pretty straightforward if you think like that. Okay?
So for this submission, we don't have to have the stairs totally figured out yet. We just have to have the top stairs, bottom stairs.
Let's take a look to be sure. So, spout elevations, curb, all that, top of stair, bottom stairs. Yeah, you do not need the number of treads and risers.
Okay.
Yeah. Okay. Anything else?
I think so.
Good, great. Awesome. You're welcome. Okay, I'm gonna stop the recording now. Stop share.